Okay guys, hello. Um, yeah, I think today we're not going to do any coding, but I want to explore some new idea. I think is explore about how can I continue with my project. So far we finished our window. See, wait, let me go to my window project folder. Go to document, cd, we go to window, project. Yeah, we compile it. We got an executable file and with a test name, and we run it. Yeah, we got the white blank window. That's it. I think I want to make this into a video players in which it can watch YouTube, YouTube in here by giving it a URL like a link. But I haven't figured out how to do it yet. Maybe let's try to understand how a video work. Like how are we pressing this a file like this, and this open a video. Yeah, like what is the process behind the video encoding and decoding? I think we try to explore that. Let's watch some video. Yeah, it's not going to be interesting or like that. If you want to follow, yeah, you can try to sit here and watch. How does video work? How does multimedia video work? Oh yeah, something like this. Oh yeah, instead of asking like that, let's see. How does video player work? Yeah, how to use video player. Oh, video player work by fetching and encoding video data from source, decoding into raw frames using a codec, and rendering the frames and audio onto the screen and speakers. It uses Media Engine to handle streaming, a decoder to decompress data, and a UI for control. How does video streaming work? I think we don't want video streaming yet, but yeah, let's just go back. Let's just go back in here. How about this one? How does the video work? Yeah, 81%. Pretty good. And
welcome to another video from explainingcomputers.com. This time I'm going to talk about digital video formats. To do this, I also need to explain digital video codecs and containers. So let's go and get started.
Okay. Format, codec, and container.
Digital video files can have many different file extensions, including MP4, MOV, and MXF. However, the first thing to understand about digital video formats is that they're not defined by their file type. This makes digital video formats far more complex than, for example, image formats, where you can be certain that a JPG file is an image in the JPEG format.
JPEG image.
Rather than being defined by a file type, a digital video format is a combination of a video codec and a container.
The container.
Codec stands for coder-decoder, and refers to the algorithm used to digitally encode a video. Meanwhile, a container is a digital box or wrapper used to store video streams and related content in a single file. It is therefore digital video containers that can be identified by their file extension and not digital video formats.
Oh, I see.
Today, a great many video codecs and containers are in use, with common codecs including H.264, also known as AVC, H.265, also known as HEVC, H.262, also known as MPEG-2 Part 2, MJPEG, ProRes, DNxHD and DNxHR.
Yeah, we don't care
Common
about this.
containers include MP4, AVI, MOV, MXF, 3GP and 3G2, and MTS, M2TS and
Oh yeah, I think for the video players, I think we will use everything in the container, and we're not going to use the codec because we don't really want to encode any things. We just need to make the video play, and that's all we want to know. I think we should care about the container.
There are many other digital video codecs and containers, but the ones listed are those I'll explain in more detail later in this video. As you probably gathered, digital video is complex and can get somewhat confusing. So, to help us get our heads around the critical concept of a video format being a combination of a codec and a container, let's take a look at one of these, a mini DV tape, which was for years a common means of storing digital video. However, a mini DV tape is a container and not a format, as it can be used to store video in 3 different ways. Specifically, a mini DV tape like this one can store video encoded with the standard definition consumer DV codec, with a professional standard definition codec called DV-CAM, and with a high definition codec called HDV. This means that it's impossible to look at a DV tape like this and to know its format. And precisely the same is true when it comes to digital video files, where the file extension indicates the container but not the video's codec.
The video codec. Oh, wait. The file extension indicate the container but not the codec. Oh, so MP4 is the container of this video. Basic window init. Something like this. That's pretty cool. So how do we get all the information in the container and then we show it? Yeah, that's what we want to do for our window. Basically, we need like a tool to get all the information inside the container like this, and then we display it into our window. And we kind of want to synchronize the picture with the sounds. So we have a video like this with this button, go forward, backward. Yeah. So that should be our basic idea. Let's see the codec.
Digital video, just like a reel of movie film, is made up of a series of still frames.
Yeah, I think we don't need to encoding the video, so we're going to go forward into the container.
As noted earlier, a digital video format is a combination of a video codec and a container. Here, a container is a digital box or wrapper that is used to store a video stream, as well as one or more accompanying audio streams and potentially other related content, such as subtitles and metadata.
Yeah, I think we need to have a framework for us to get a video stream, audio stream, or all this information, and we want to display it to have this video. Yeah, just like what I said before.
Containers include MP4, AVI, and MOV. MP4 was defined by the Motion Picture Experts Group in their MPEG-4 Part 14 specification. AVI was developed by Microsoft and stands for Audio Video Interleave, and MOV was created by Apple and is short for movie. All three of these containers can store video encoded with many different codecs, with MP4 and MOV currently having the widest range of both professional and consumer applications. More niche containers include MXF, 3GP and 3G2, as well as MTS, M2TS and TS. M2T.
I think most of us are not very familiar with all of this. We mostly use MP4, so
and
I guess I'm gonna
position videos recorded in the still XAVC-L format used on many Sony cameras, then store 826 codec and an MX.
We usually use this one, MP4. Yeah, that's kind of not how
container
to
or 826 ProRes format and
DSLR.
Stored in a
Hey, I think I noticed on the camera. I saw this on the camera.
Container often lacks specific format name. Files usually takes place in an MXF container.
Okay, I think that should be enough. The video is kind of long. I think you can watch it on your own, but it's very helpful, and I think you should watch it. Okay. So we in this our summary, we know that everything we need from the video is inside the container, which is MP4. We need a video stream inside it, audio stream, subtitle, and data. So we need something to extract all of this data. And I think I have an idea. I think I saw it on GitHub. Its name is Build Your OS. Build Your OS GitHub here. So I think in here you can find a lot of projects, and they will show you how to do it. Here you have a Build Your OS renderer. You have C++, Java, JavaScript. Yeah, and when you click on here, they will have all the tutorial that you can follow, and it's super helpful. Yeah, you can read the whole documentation. And in here, after searching for a little bit, I found this one. Go to the end, go to the under categorizes. You will see learn how to write a video, how to write a video player in less than 1,000 lines of code. So I think you can follow this one, and basically they also use SDL and another framework called FFmpeg. It is a wonderful library for creating video application or even general purpose utilities. Well, some of the thing in this tutorial is very old. It is in 2015, and most of the function they use in here is not working anymore. Some function like this, because it's been more 11 years and a lot of them have been updated. So if you try to follow this tutorial, your code might not be compiled because the function is no longer exists or had been replaced. So we need to figure out how to. So you should not try to code exactly like this, but try to understand the process of how they do it. So I think okay, so before we do it, let's try to download the library FFmpeg website, just like we have with SDL 3. Here we have the SDL library in here. and we also need the same like this. So online, getting started, Impact API, yeah, documentation, we can read that. Okay, I think we need to download the library. Do we have a library in GitHub so we can clone it? Oh yeah, here, GitHub, app. Yes, let's use this library. I hope this one should be. Oh wait, this is not the real one. It's just the sheet. App, not this one. Oh wait, oh it's not the official website. Oh, it should be this one right here, appampack.org. Yeah, we can download it like this, but we don't want it. We actually want all the source code, so we need to find the GitHub of it. Documentation, new, community. Yeah, okay, you should go to here, source code, app macOS, and we can use this one. We can use this. Yeah, Git repository. Let's go here. Man app impact. I think we can use this one. I think it should be the official GitHub for it. Yeah, I think we can use that, or I think we can try to follow this one right here. Yeah, I think we can use this one. We can use this one. Don't copy all of it. Just into this is enough. Copy. Okay, let's go to just to make sure that you place that right next to your Windows source code. Well, it's just easier to link the library that way. Yeah, git clone. Let's see if it work. Please work. The GitHub. Oh yeah, it should work. We can try to inspect the source code. The source code. Yes. App impact. Yeah. I think you can let's see the meme. Let's see. App impact. Well, basically most of the program right now use app impact. And yeah, like here, yeah, like every other thing like YouTube, Facebook, Meta, Twitter, TikTok use app impact. Like they are the they actually like the a bare a bone of the software that we use nowadays. I think it's pretty cool to know. Okay, we have all the source code. Yeah, we got all the tool, the lib format. Cool. Do we have documentation? I think we should read the documentation in order to know how to use it. Leave AV codec. Yeah, I think the first thing. Okay, let's try to follow the tutorial. Yeah, so we have the source code. We have all the function in here. Then we just try to figure out how to use it. Yeah, the first thing we want to do is opening the file. So we need these two library, AV codec, live AV codec, AV codec.h, live AV format, AV format.h, app impact, WS scale. So we got AV register or the main function. We want this one, AV open input. Oh, yeah, I don't know how it works. I never used it before. Format converter, encoder and decoder, codec. Oh, I think this should be it. Lib scale, AV format. Oh, we want to opening a file, right? So encoder and decoder. Description. This document describes the codec, decoder, and encoder provided by libav codec library, right? Yep, we need it. So, libav codec provides some generic global option which can be set on all the encoder and decoder. In addition, its codec may support so-called private options, which are specific for a given codec. What does that mean? I don't know. Sometimes a global option may only affect a specific kind of codec. How do we, like the codec is how we encode a video, and maybe nonsensical or ignored by another. So you need time to be aware of the meaning for the specific option, and some options are meant for only decoding or for decoding or encoding. Option may be set by specifying option value in the FFmpeg tool, or by setting the value explicitly in the AV codec context option, or using the libav-util obt.h API for programmatic use. Encode. I think we want to decode the video. Maybe we can use that later. Is that the function name? Do we, what register, or what does this mean? Register our codec with the library. I think we need this one, right? Let's see if it exists in here. Yeah, this might be very boring, and well, it is a part of the process of how you build something. You have to research about it, and you have to read a lot, because we don't know anything. And if I just try to summarize it, it will lose a lot of it will be a lot of information, and it will be like a brain rot on YouTube, because they have everything for you. But in reality, if you want to make something, you have to understand it yourself. Yeah, that's why if you kind of bored, you can read all of this with me, but I think it's not in here. Encoder, register. Do we have something in here? I think this should be in the categories. Why do we need this? Why do we want to register our codec with the library at the very first line of code? Yeah, this is the very first line of code. This registers all available file format and codec with the library, so they will be used automatically when a file with all the corresponding format or codec is open. Oh, so I think in summary we will need this, because if we use this, it will work for all the format that they use. Yeah, like all the format like this. Yeah, if we use that, it will work for all the format. This one. So it will be used automatically when the file with the corresponding format, the codec, is open. Yeah, that makes sense, but it's old. But let's see. Raw video, register, codec option, audio codec. What is that? Do we have that thing? We need to know what does this do. We cannot just we don't want to copy and paste without understanding what it really does. we have to know it because it's going to help us in the long run. Yeah, I know some of you might say that it is boring, I don't want to read it, but well, it is what it is. You must know how to do it. Muser, the muser. Oh, I think before we read that, let's understand the overall process of video player. The process of media player. The process of media player. Video. Okay. The process of watching the process of watching a video. A video. The process of showing. Process behind playing a video on the screen. Yeah, this should be help us understand what happened when we press opening the video, like this one. What happened when we press this video right here? How does it work to bring the video in here? Yeah, I think that's super important. No, I think I saw that before. Okay, compressing a file, decoding it into individual frame. Oh, okay. I think we don't need to. The process. I think we can add ChatGPT for this because it's not like I'm vibe coding, so I think it's a good path. Hey, what is the process to show the video on the screen? Like on the screen, what happened when we click on the video file .mp4 for example? Yeah, when you click on a video file like mp4, quite a few things happen behind the scene to get that moving image onto your screen. Here's the process in clear real workflow. So operating system here when you click the file, okay, the media, when you double click the file, your operating system like Windows or Mac OS recognize the mp4 extension and decide which app should open it. Maybe VLC, media player, media player. I think for Mac OS, when I click on the video, they use QuickTime players. I think that's what we're trying to do with our project. We want to make a very simple version of this app. Then the media open the file. The chosen file load the file onto your storage, into your memory. Yes, so you just play immediately. You need to understand how the data is structured. So I think basically it's like it have to read everything we have in the container. Yeah, it's going to read it's going to read all the video stream. Yeah, it's going to read the video stream, the audio stream, the subtitle, and the metadata inside it. So it should be the process of it. Yeah, I need to understand how the data is structured. Yes. Container format is passed, or something like this. The container format is raw video. It can hold video stream, compressed image, audio stream, a subtitle, metadata. Yes, here we all this. The player read this structure to separate those parts. So basically, that's what we want to do in here. We need to open it, and we need to load it into the memory, and decode the data. The video and audio inside are compressed using the codec like all of this. The player use software and hardware to the hardware decoder to decompress its data into raw frame and sound. Yes, I think that's what FF Mpeg will come into play. It had all the library to help us to decode and encode the data. Yeah, that's why we use this. So this I think FF Mpeg we have with this one, and also this one. And frame are sent to the GPU. It decode video frame basically in image. It passes into the graphic system. Yeah, then FF Mpeg once again will handle this job. It will deliberate it into our graphic system, like on my Mac. Convert to pixel, scale into fit on the screen. Yeah, I think SDL3 will help in this process. Our audio speaker at the same time stay synchronized rendering system. Continue update the display. Yes, we use SDL3 for this process. We see the buffering, getting smooth by buffering upcoming data. Sync audio and video, dropping delay. Okay, so yeah, so for this tutorial, I think they will try to do the process of processing it. So let's ask ChatGPT about how does the video it passes. What is the process? The process using FF Mpeg library. Yeah, I think we want to have that. Good thing under the hood, the process of passing the plane video Mpeg is very structured and modular. Let's walk through what happened inside FF Mpeg when it processes the video. So first of all, it's going to open the file. Yeah, we have the function for it. Very convenient. You can use this function or not. Yeah. I think we don't have to read it. Just read it here. Opening the file format player. FF Mpeg start with the libav format module. We're going to use a function to open the file. Open file and detect the container format, MP4, MPK, etc. Oh wait, I think I can see it. So for example, this one, right? We right click it. We go to how do we see information in here? Get info. So basically, this file right here is MPG4 movie. Name and extension. No. Yeah, it should have the file size MP4 movie. Then it's going to use this function to scan the file to discover how many streams it exists. Oh, video, audio, subtitle, what codec are used. I think we cannot really see it in here. Can we will see the codec that they use? No. Oh, that's sad. Comment, name, attention, sharing permission. Okay, I think it's kind of limited, so you cannot see it. Yeah, so first of all, going to open. It's going to get all the metadata data, like the name of the MP4, how many streams exist, and then it's at this point it's just understand the container. So move to the next one. Go to passing the container demusing. So let's just talk about demusing. Step called demusing. The container MP4 is split into the separate stream. Well, I think from my understanding, this MP4 had the video and audio stream stored inside it, and we kind of need to decompress all of this. Yeah, decompress it. So the next one, finding and opening the decoder. For stream, FFmpeg identify the codec. Load the correct decoder using this library VIV codec. Typically flow find decoder, allocate a context, codec open. So FFmpeg is ready to decode the packet. So it's going to reading the packet. We have to read it. Back into a loop. AV reframe. Read one packet at a time from the file. Each packet is belong to a specific stream, and it's going to decode packet into frame. This is the key step. Send packet to decoder. We see decode frame. Now you get a frame which is uncompressed image of data video. Oh, so after this one you will have one single frame. Oh, reverse compression, review pixel data, reconstruct frame using previous one. So yeah, they can see it like this. We go to demuse, compress, decode. We got a frame. I think I still don't understand it. Build. I think I saw someone did it. Did build media player. Build media player. The secret of media player. I think I saw someone did it. Where is it? I think someone in C. Can I use this one? Build a media player. Oh, I think someone explained it right here.
See an MPV handle display.
I think you can watch this one. I hope I can watch all of it. Or I think I will be kind of bored and quit in the middle.
We're really going to do this, right? We're going to make a multimedia player. All right, let's go ahead and do that. Hey, if you're new to this channel, my name's Rob. I'm a coding instructor for Pre-Code Camp. And in these video series that we're doing, we are going through step by step with the labs as well as workshops that Pre-Code Camp out there offers for you. And one of the benefits of watching these videos here that I make is that you get a little bit of an instructor's point of view where we are going to be teaching you a few things along the way. And if you get stuck in your trying to do it by yourself, that's where these videos are trying to help you and making sure that you are understanding things and finding things in the right documentation.
Yes.
So if that's something that interests you,
Yes,
hey, keep watching. And if you can do us a favor here, make sure you hit that like button because it really helps out that YouTube algorithm.
Not yet.
With that being said, let's go ahead and dive into what we're actually going to be creating with the Build a Multimedia Player. Okay, so typically,
Yes, I hope I will like his video.
you're at this point in the game, you kind of know a little bit about free code.
Oh wait, he gonna use HTML file. I think he's not going to touch all of this low-level library. So This not what are we looking for. Main title.
Okay. So user story number 1 is, it says that we need to have an of a single.
Yeah, I think he used HTML. We kind of work with a low level, like this one. Let's watch this one first.
Producers, this plugin helps you finish.
Wait, just
Like VR.
okay. Impact.
When you watch a video, you're not really seeing motion. You're seeing hundreds of still pictures flashing by every second. Your eyes take snapshots like a camera and predict motion, filling in the gaps in between each picture. That's how videos are able to pass with low frame rates to our eyes, but look completely smooth. Each picture that's displayed is made up of an array of pixels. The spectrum of visible colors we see is made up of 3 subpixels: red, green, and blue, or RGB in short. We can add an amount of each color to form every color we see. This is called additive color mixing because you're adding light together. It's the same technology you see from PNG files to your monitor screen. So motion is an illusion created by your brain, and color is an illusion of RGB lights. Put those together, and the video is really just tons of images flashing by every single second. But here's where things get tricky. Building something that can decode information and display all of that fast enough is harder than it sounds. When you take any video file on your desktop and try to play it, a decoder first extracts the image, audio, and subtitle frames to the player, which then handles the timing and the rendering.
Oh, so that's what we want to do.
But here's the twist. I kind of lied earlier. Most videos aren't usually stored in RGB. The reason comes back to biology. Your eyes are more sensitive to brightness than color. Most of the details, like edges, shapes, and textures, come from light and not hue. Our eyes are bad at spotting small losses in color information. Take a look at these 2 images and tell me if you can notice the difference. Video formats take advantage of this by separating brightness from colors instead of storing full red, green, and blue values. The brightness is kept at full resolution, while the color is stored at a lower resolution to save space. This format is called YUV. So when the decoder I use, FFmpeg, decodes a frame, it doesn't give us RGB pixels right away. It gives us Y, U, and V planes, which we later have to convert back into RGB to display on our monitor.
Oh.
But even when we have the pixels ready, another challenge still remains: figuring out when to show them. Now, as it turns out, timing the images in a video is incredibly difficult. And just for now, let's just focus on just the image part. We're lucky that FFmpeg is able to give us timestamps for each image when we decode the video file itself. But how do we know when to display it or not?
I think he's talking about synchronization. Like you need to make all the frame and the audio in scenes to have a complete video.
Solution is to line our images up on a timeline and keep a running timer using STD Chrono. For each image that FFmpeg gives us, we compare the image timestamp to our current clock. If our clock is behind, then we skip this image to catch up. Otherwise, we want to sleep until we display our next image. And by doing this, we're able to time each image we show at the best time.
Hey, he actually used FFmpeg library in C++. I think it works in let's see also, so it's not a matter. Initial timing, sleep until target. Yeah, I think we don't. I think for most of our part, we don't need to care about this one. Yeah. Hey, I think we can copy it on the screen. That's cool. I think this is the feature on MacBook. That's really cool. Hit the time frame. Check if the time frame is valid. Yes. Initialize the clock. Oh, start clock, start time, chrono. Time started true. Cons, audio. Sleep until. Oh yeah. We only need to. I think the main code in here is this small function right here. All of this 1, 2, 3, 4, 5 function is the how the function work. So example is valid timestamp. So how this function work is in here, and how this function and this is initialize timing me is here. This is how it works. Cause audio calculate time. Here calculate time here. Sleep until target. It should be this whole thing.
While this theoretically works, it begins to fall apart when we play higher resolution videos. Our algorithm relies on the operating system to sleep for an exact amount before the next image, which is usually wildly inaccurate. And I won't discuss these reasons in this video, but I really encourage you to watch a video on OS scheduling if you'd like to learn more.
OS schedule.
In the C++ specification, thread sleep will sleep at least a specified amount, so 1 millisecond could actually mean 10 or 15 milliseconds in reality.
Oh.
So that doesn't seem like a lot, but overshooting that much can cause us to lose an entire frame. For example, at 60 frames per second, each frame only gets about 16 milliseconds of screen time. Oversleeping even 15 milliseconds will cause us to be late for the next frame. Even if our timing were perfect, there's also still another problem. Our algorithm doesn't take into account rendering time. Uploading textures, copying data to the GPU, and drawing the frame all take longer as resolution increases, and some frames won't be ready when our timer says they should be. So if both the OS and the GPU are introducing unpredictable delays, how can we schedule when the next frame should appear? Now fortunately, the solution is already in our hands. The monitor that we use to view videos runs on a super precise clock. They refresh at a fixed rate, most usually 60 Hz, and with vertical sync or VSync, the GPU is able to display frames exactly on each individual refresh.
Oh.
So instead of sleeping and praying we wake up on time, we can prepare the next frame and let the GPU handle the timing for us. And as it turns out, this is the way that most modern video players like VLC and MPV handle display.
Ah.
To upload to the GPU, we will be using both vertex and fragment shaders from OpenGL. If you remember earlier, since monitors store color in RGB and the color we get from videos is YUV, we need to be able to convert from YUV to RGB fast. And we can do this on the GPU, which you can see in the shader code for super fast conversion. So far, we've focused on the visual side, but a video player has to handle more than just images. It also needs to play audio and keep everything in synchronization.
Wait, something is misread.
Audio-video synchronization is another challenge on its own, but for now, for audio, we're going to use OpenAL to play audio samples through devices. FFmpeg doesn't just decode video, but it also gives us audio samples. The audio devices we have today, like speakers, headphones, or AirPods, support a different number of channels and sampling rates. The audio samples that we get from FFmpeg are called PCM, and they can have various formats, sample rates, and channels. And because of that, we won't necessarily have the specification of the audio device we are playing it on, because they have their own format, sample rate, and channel too. To fix that, we have to resample our audio and convert it to our desired format using SW Resample. And after that, we're able to feed our samples into OpenAL and play audio alongside our video.
Oh man, this is so complicated. I think we need that later.
The video breaks. The easiest way to keep everything aligned is to use a master clock. Like a symphony conductor, the master clock will determine exactly when audio packets are played and when video frames appear on screen. But who should control that clock? We really only have two options, video or audio. At first glance, it feels like the video should lead because that's what we see. But as we mentioned in the beginning, your brain naturally fills in gaps and predicts motion, so small frame drops often go unnoticed. On the other hand, audio is different. Your brain catches audio drifts instantly. Your ears don't fill in missing samples the way your eyes fill in missing frames. When audio falls out of sync, footsteps feel disconnected, dialogue is confused, and music loses its impact. Because of this, most modern media players often use audio as the master clock. It's far less distracting to drop a video frame than it is to let the sound break immersion. So how does this all work together? Well, we first send samples to an audio device which plays them at a super precise rate. That timing is controlled by the hardware and not the OS, so it's super stable and reliable. At any moment, we can ask the audio device what timestamp it's currently playing and treat that as the true time of our system. We can reuse our logic when we display images, except that instead of using the operating system's clock, we are using the audio device's pulse. In reality, titles, hardware acceleration, or the dozens of different formats that real players.
Okay. Oh, I think I can use your GitHub. Source code. Oh wow, look at this. Yeah, I think that's all for today. It's 4 p.m. I have to go. I think I will be back in the night. Bye guys, I will be back. Okay guys, we are back from the library. Yay. Hey, it's working. Well, it's 11:54 at night, very late. I think we will work on it for a little bit and then I will go to sleep. Work on it tomorrow. Well, yeah, as you know, we did viewing a little bit of documentation, how things work, and I think we got a general idea about how it works and what kind of things we need to do. So today let's go to the right now let's go to the coding and yeah, let's go to the coding let's see, we can do something. Let's go to the website. It's called Build Your OS. I think you go to the categorize right here. How to write a video player in less than 1000 lines. Yeah, press it. I think you should read all of it. It's very knowledgeable. It can help you a lot in understanding what we will do. So let's make a file. Let's follow the tutorial. Yeah, let's go to cd document, cd window project. Let's make a file. Touch string cap. This is string cap. We want to make a string cap, right? Okay, touch string cap.c. Open string cap. Away string cap.c. Yeah, we have the FFmpeg library ready. Yeah, that should be good to go. So yeah, let's move to this side. This one have right, not to the right. I think let's drag this up a little. Now let's not cover the time. Yeah, maybe a little bit more. Yeah, it's match this line. Okay. So what do we have? Let's read the overview. Move files have a few basic components. First, the file itself is called a container. As you know, we watched a video in the morning, so it should be reasonable, and you have a basic understanding of the container. And the type of container determine where the information in the file go. Example of container are AVI and QuickTime. We have a QuickTime here, really. Next, you have a bunch of stream. For example, you usually have an audio and video stream. A stream is just a fancy word for a succession of data element made available over time. The data element in the stream are called frames. Each stream is encoded by a different kind of codec. The codec defines how actual data is coded and decoded. Hence, that's the same codec. Example, the codec are DIVS and MP3. Packets are then read from the stream. Packets are pieces of data that can contain bits of data that are decoded in frame that we can finally manipulate in our application. For our purpose, each packet contains complete frame or multiple frame in the case of audio. So basically we have the stream in here and we want to read it. That's where our frame and the sound, and we have to use the specific codec in that a container, yeah, okay, at this very basic level. Dealing with video and audio stream is very easy, so we have a little bit of things to do. First of all, we open the video, we open a video like this. We press open, not like that, and we read from the packet for the video stream into frame. If frame not complete, go go back and repeat this one and do something with the frame, and we repeat this process. Yeah, repeat this process over here until we run out of stream. Yeah. Okay, handling multimedia with FFmpeg is very much as simple this program, although some program may have a very complex do something step. Yeah, do something with frame. I think we can twist it like video editing for this one. This video editing also use FFmpeg. I think yes. Does it? Does DaVinci so use FFmpeg? This is like FFmpeg voice call and coding, heavily used by user to convert and support file. Oh, we said that you FFmpeg. Oh well. It's just a library. I think they are professional. Yeah. So in this tutorial, we are going to open a file, read for the video stream inside it, and do something. It's going to be writing the frame to the ppm file. But what is ppm file? Okay. Let's read from this document. The ppm file format store color images as bitmap file. ppm are rarely used today because they are compatible with standard Windows software. Really? Portable pixel map is a simple uncompressed raster image format commonly used for storing basic color photographs. Editor is a part of Net ppm toolkit. Oh, I'm not sure what's that, but I think we can care about it later. Yeah. First, let's see how we open a file in the first place. With FFmpeg, you have to initialize a library. Okay. Let's initialize a library. Include lib av codec av codec .h and include lib av format wait, not that one, av format .a include let's see, FFmpeg SW scale .a. Okay, let's make a main function with command line argument of C charge. I think you can instead of writing like this, you can also make it like this. Make it a double pointer. It's worked the same at this one. RV, yeah, it's worked the same. Okay, let's go AV register or okay. I'm not sure, but like make sure that we don't have to link all of the libraries. Wait, how do I link library? Let's add ChatGPT. No. How to link library inside a directory for C program. To link library. Dynamic library. I think we can watch this video. I don't want to rely on ChatGPT too much.
Hello ladies and gentlemen.
It is way too loud.
Today I'm going to show you how to create a dynamic library, and the first class I show you how to create a static library. So I use the same files to create dynamic library. The only thing I do here is let me delete all object files from here. rm then start.o.
Oh, I think this is the directory with the library inside it. So I think it's working the same as ffmpeg we have. Yeah, we want to go inside this directory and use all the function like that or like this one. Let's see.
I delete it, and again I have to delete this static library executable file and this just static library name. So to do that, just let me rm just static again rm just lib. So here I have these two functions add.c and sub.c, then one main functions main.c and one header file just main.h file. So the first thing what I have to do here is also just I have to create the object code, but creating the object code in static library and dynamic library has some differences. That is, in static library I simply use gcc then -c to compile it, then my file name add.c and sub.c. This is it, how I create my libraries, my object file in creating static library.
Yes.
But here I will add -fpic flag. This flag used to create a position independent code that can be called dynamically. So here I use this flag. Let me press enter. After doing this, just I have already all object files. Then the next step just to create just a library or dynamic library name. To create that, let me list all object files here. I.o and sub.o object files I have there. So here I have to use gcc then minus I didn't compile it, just I use all files starting from with ending with .o extension. Then I use another flag, dynamic link. So
Not what I'm looking for. Having static shared library.
I did it!
Yes, you did it. Good job. But it's not your effort.
So you're gonna tell me where to...
Hello and welcome to this C programming video. In this video we're going to be more talking about how to use GCC to create a shared static library and then create an executable file that uses or links that library and uses some of the functionality. Rather than me explain it, we're just going to jump straight in so you can pause on the screen and see roughly the steps that we're going to be taking in this video. With that said, let's create both of our folders, because we're going to be creating an app and we're going to be creating a library as well.
Yeah.
And within inside of the app, we're just going to say main.c, and inside of the library we're going to create another folder called include. This is where the header file is going to go, and also where our my simple library.c file is going to go. With that said, let's just create a my simple library.h header file for it, and now we have all of the files that we need. So let's just declare what our main C is going to look like first of all. Let's just budge that over to the right, and so we're going to need to import my simple library.h. Obviously it doesn't yet. We're going to have to import that my simple library,
Yes,
And
I
with
have
inside
here.
of here, we're going to then
Yes, we have it here. FFmpeg. The same as the same structure. I think we have the same structure in here.
our main function. This is going to return
Return 0.
0, and we are then going to create a message variable, and it's going to say I am some text in the main.c. Okay.
I am some text in the main.c.
And then we're going to say hello, and this is the method, the function, sorry, that we're going to be exporting or including with inside of our library. So now that we have that, that shouldn't really work, right? We're not going to run it because we haven't got this library as of yet. So let's close that down, and let's come to our mysimplelibrary.h file, and let's declare this function in here, and we'll just say const char and then message. That's what it looked like. And now we're coming to mysimplelibrary.c, and we can create this file. Okay, in here we're going to printf.
Oh yeah, I think I want to talk about this one little bit. That's how you organize your project. I think some of you know, some of you don't know. So instead of having all the function inside one file, we kind of split it up. We have the header file. It's going to declare the function signature, and we're going to have the util file that's going to tell what that function is going to do. Yeah, and that's what basically he do, and this help organize the project by a lot. FFmpeg also did the FFmpeg, and SDL did the same thing. That's why they managed to make the complicated project very clear to use and fix.
To the terminal. So we're going to need the standard io.h, and obviously we're going to need the my simple library.h as well to import then the actual function here. So next we're going to say printf, and inside of here we'll just say the message is then question mark then s, and we'll give it a backslash n to go to the new line, and we'll add then the message here as well. Okay, now that we've done that, we've literally made our incredibly fantastic application. The time now, so we've created our simple execution application that uses the shared static library. We've created the shared static library. We now need to compile the O file, compile the library's O file. So we've got to come and compile this C file first of all. So let's just come to the terminal, and we're going to do that using GCC. And we first need to say that the output is going to be my simple library, and it's going to be the O file. All right. And we now need to say that we want to to compile some code, and we're going to say then the library, and then my simple .c. So we also need to tell it where to look for the headers, and that's done by using the big I, the -i flag. And in this sense, we're just going to say library and then include. All right. So
I think we need this one. I think we don't need the C. We just need that I, because we essentially don't need all the header file in here. So GCC wait, no. String capital C .o let's do test2 that I let's make another terminal. Yeah, cd window project. I think you can use it by pressing Command Shift D. Yeah, Command Shift D or Command Shift S. No, it's not Command Shift S. Or Command Shift F. No. I think that should be good. Yeah, with Command Shift D. Window project, ls cd ffmpeg. I think where's the library? libav codec. libav codec. Yeah, it's right here. Head the file. ffmpeg. ffmpeg libav codec. The codec. Is this correct? I don't know. What did I do?
Telling it what the output should be. We're telling it which.
Oh wait, I just need this very broad. Oh, is this right? I think I don't know. Leave AV codec, AV codec. It's correct, right? Yeah, AV codec. Wait, does it need ffmpeg? ffmpeg. This, yeah, I don't know how. I never tried this. Yeah, that's the first issue. Yeah, no, I don't know. Anglers and glue. Huh? Oh wait, what? I think it's how does it work compared to the double quote? Why do we use in glue and C? Why do we use in glue and C? In glue and C. Yeah, let's read this one. Professional. Main access pre-existing system header file in the standard system directory. Oh, in the system header file. This one doesn't exist in the system header file. Wait, where's the system header file? Where is the system header file on macOS? SDK. Oh, user. Oh, it's right there. Yeah, let's see. CD. Go to the root. CD USR. CD. Wait. What? Lib. Oh. Wait. No. CD bin. Oh no, not here. CD lib. Do you have libav codec in here? Oh, yeah, no. CD sbin. Let's go to sbin. Do we have something in here? Oh. Yeah, I guess we cannot use this one. Okay, oh wait, CD system, no, CD library, Do we have FFmpeg? No, we don't. Message. Yeah, we don't have it. CD user, my name. Okay, I think we have to use this one. User DB file. Yeah, have to use that one. Understandable. Okay, let's make a lot of sense. Yeah, this tutorial is really old. We have to know what are we doing, or else it won't work. FFmpeg. Okay, let's see. Quite, just to make sure, save it. Clear. Oh wait, do we need this? Oh, I think we don't need this FFmpeg. Oh. Oh yeah. Why? What? Huh? Even the file is not correct. Oh, I think I did something wrong. CD FFmpeg. CD lib. Yeah, lib AV codec. Open AV codec. .h. Oh wow, that is wait, how do we? Yeah, okay, clear. Big library like FFmpeg in the project. My include is not working. Include is not working. My include is not working. Copy. This is my include. Okay, let's see. Yeah, we need to keep all this information. As you are very close, choose the classic machine learning about FFmpeg meant to be used in a C project. Trying to treat FFmpeg like a header folder, include manually. Set up compile library, public header, but because you configure metadata. The error, C header, the core of your approach. Oh, and this. This is the key. Oh, okay. So the root of the problem. So basically, the root of the problem is FFmpeg is a set of compiler library, public header, because you can configure metadata. Oh, depend on each other, like a structure. to apt in the system. Sudo system-wide sudo. Oh, sudo make install. I think we can use that. I think we did the same with SDL3. Config. Oh, what? Oh, I think we don't want the system while, so we can do it locally. Yeah, I think we can do option B. Config. Back peel and glue. Wait, can you explain option B? Oh, the inside directory. Step down CD and then back to install itself. Install everything into your home folder. Oh, tell you, go to that config file. Configure. Oh well. Compile everything back. Oh, what? Wait, let me give ChatGPT one more piece of information. Generate config view configure. Oh, I think I have this thing. Let's see, cd configure not a directory. Oh, here, ffbuild, cd ffbuild. Oh, open.e pkg.config gconfig. Oh, right here. Oh, wow. It's only half it. What? It's only half that. We don't need to. Yeah, I don't need this one. No, I think I don't need it because it's only half that. important. Okay. Configure. Oh well, I think someone already did this and they post this online. That's why ChatGPT was able to figure that out. Okay, cd what? Let's paste this. Configure prefit. Emboss here. Store everything into your home folder. Add to home folder. Yeah, I need more information. Okay. What is this? You make it in the directory, not home folder. Yeah, I don't want to be in home folder. Okay, yeah, I think I'm going to delete that. Command. Yeah, it's kind of hidden. I think we want to remove that. cd.config. What is that? Yeah, I think let's fix that a bit. Wait, cd.config. No, not in here. Wait, where's that Mac field? What did I run? Preface home. Oh no, that was not a good idea. Wait, where does it go to? Yeah, this should be it. This should be it. Wait, where did I install it into? What? Oh no. Oh, dang, I thought this. about I try this one? Try this one. Yeah. Oh wow, I forgot. Catch config logo. Okay, that was not a good idea. Where is my back view? Oh wait, let's see, where did this go? I think the command is not correct because command unchanged, the music unchanged. Wait. Okay. Yeah, I try to follow it real quick. Copy. Wait. Yeah, I don't trust. Maybe I should trust ChatGPT that much. Wait, let me take some break for my eye. Oh, okay. Let's see. Pew. Oh man. Yeah, let's go this way. Yeah, it's way more convenient this way. Easier to see. Just wait for a moment. I think in summary, you should try to do it the other one. You should do it this one. Yeah, PWD. Wait, my CPU is working harder. Oh wow. Oh, it's activating all my CPU. It's activating all my CPU. My fan is spinning. Okay, my fan is spinning really hard. I mean, wait, make this clean. Should I do it? Going to break my computer? No. Yeah, I think I can try it. How about I try this one? window project. Okay, I think no space should be good, right? Configure. Wait, how about set FM back to CD window project. CD FF build. Wait, can I change the command a little bit? Can I change the command a little bit? Well, instead of let's do it with oh wait, no, wrong command. It should be this one. FF build. Yeah, should be this one. FF build. Please go to FF build. Not. Yeah, I think ChatGPT got the solution from the old internet. That's why it's not that working. Oh, we need to generate a dilip. Yeah, let's take a while. It's generating. I think it's work. Okay, now force my CPU to work extra hard. It's gonna turn on the fan. No, what happened? Keep going. This occasionally error. Wow, so many warning. Ah, it's working extra hard. Yeah, I have no idea what I'm doing. Okay, there's no error. There was no error. And for the last one, make install. CD FF build. Okay. And what's next? No, let's not use this one. Okay, let's try to type the command. Where's the command? Okay, here. There we it. No, not this one. Oh, what am I doing? Okay, everything works somehow. How to compile again? Okay, let's turn this up. Wait, what is the back does? PW. Instead of that, we're gonna use PWD for this one. Okay, GCC string cap. Wait, CD GCC string cap test2, include this one, I $ pwd, include this one .l pwd lib, and this one also LAV codec. Not COVID. Yeah. LAV format. LAV util. LAV LSW scale. Oh wait. CD FF build. CD include. Oh, what? Huh? Oh wait, can I config that SA? What is that? Oh wait. Oh, export. I think we can export it in here. Yeah, they use it as export. Wait, I can modify it a little bit because it's missing something in between. Windows project. We had to go to app and back. Had to go to app and back again. App and back. Yeah, should be go to. Wait, no. App and back, and let's go to app build. Yeah. No. Oh wait, no. App build. Do we have a lib? Oh, app and back. Screen cap. Let's see. Oh wait, no. Yeah, let's try once again. Okay. make the, let's do, oh wait, cd make no, yeah, okay, not doing this, it's way too complicated. Yeah, let's do something else. Let's use the make file. Okay, let's there's no such thing at this one. I wish I had a good teacher. Wait, let me try. Huh. PKG config. Okay. CD. So, basically you have to run the Okay, this is what you have to do from the beginning. So first of all, make sure that you don't have any space in your name object folder. Second of all, run this command. Run this, go to ffmpeg, and then you run this command. You run this command right here. Oh wait, no. You run this command right here. Run this command. I think you don't need the space, the enter key. Just this is enough. Yeah. Here, run this command. Yeah, run this command. I think it's correct. After that, you can after that, you run the command. If you use macOS, you can use this command right here. Yeah, and after that, you can make install. And for the final step, just run make install. Voila, that's how you do it. Okay, now to link the library, you kinda want to specify you want to have the path that work. I think I will do it manually. It's cd. Yeah, this is what you want to do. You need to identify where's the library. cd ffmpeg, cd ffbuild. Yeah, you need to identify this one and this one. So pwd. So basically it's in here. It's two of this is in here. So for the L and I include, you just need to make sure that it get to here. You can have a shortcut all of this by using like this here. gcc. Oh wait, cd. Yeah, you can have a shortcut. gcc screencap c z2, then you separate it. You need the header file using .i. Okay, you basically want to include all of this in this one in this one before the include, but you can simplify that by doing the $sign pwd, and then you can go to ffmpeg, ffbuild, yeah, and then include. Got it. Then you separate it with it. We need a library. Now need a library. Just we work on the same thing. pwd, ffmpeg, ffbuild, lib, there, build. Then you need all this LAV codec. .lav codec, LAV format, LAV util, and LASW scale. Again. No. Wait, did I do something wrong? Yeah, I think I did something wrong again. this one. Ah, I need a double quote. I need a double quote. Double quote. I need a double quote. 36%. I need a double quote. I need a double quote. Wow. Oh, I need a double quote. Wait, what? How? How is this still not correct? Oh, did I do something wrong? Side PWB. Wait, can I? Does it work with the PKG config? Does it work? Does it really work that way? Copy PKG config. Copy like this. PKG config. C flag. Lib AV codec. Lib AV format. Lib AV YouTube library SW scale. Oh wait, it worked. I think I don't need that. Then I can just, I don't need to use this long things. I can use PKG config because I only have it inside our lib. Yeah, inside our lib. It's here. It should be here. Yeah, we go to lib and it's somewhere around here. So gcc swing cap.o test2 $sign pkg config c flag and yeah, let's include all these things. Copy, close it. Okay, it worked. The only thing problem is this scale right here. I think we don't need a scale, do we? Where's the lib scale.h? Oh yeah, I think we don't need it. I just need a lib scale. Lib SW scale. Yeah. Let's see if it works. Oh wait, it doesn't do. This is the same file. Yeah, it should be. I think I save it. Why does this still have this one? Oh wow. Go to back to document. I was in the wrong folder. I was in the wrong folder. I was in the wrong folder the entire time. AV register car. Okay, so everything worked, but this window project. Okay, yeah. rm.rf this day delete AV register car. In event impact. Did already remove it? Yes. Yeah, this makes sense because this was written in. Because this was written in 2015, more than 10 years ago. Oh well. Oh, yike. Oh. Yeah. Absolutely. Okay. Bye bye. So I don't need that. Well, yeah, just make sure that it works. Let's compile it once again. Yes, it worked. The library worked. So what do we do now? Let's AV format contest. We get a file name from the first argument. Oh, this function will read the header file and store information about the format. File format, context structure. Oh, this one is a struct. Oh, AV format context is struct. So it's going to get the timestamp, the title, the author, copyright, comment, album, year, track, genre. Wow. So it's like start time, duration, price, highway. Yes. So to go to the struct is allocate on the memory. Wait, I will be back. Okay, I think after I be back, I spent like how much did I spend? What did I spend? I spent like more than an hour recording, and how long is it? That's more than an hour recording, and it doesn't work. No, I spent like 21 minutes, and the video doesn't work. It's only the same screen. I think I explained a lot of things in there, but yeah, I think I will summarize to you. Okay, so this is how it does. Let's go to document again, cd window project, open string capacity. Okay, so basically the for the old tutorial Visual OS and categorize we don't need to call the register call at all. They updated a long time ago, so we use the network in it. This is optional but recommend, and after that we need to open the file, but we need something to store all the meta data, so we use a struct that FFmpeg gave to us. This is the struct, and it's going to help us store all the metadata like timestamp, the title, the author, the copyright, the comment, and everything everything is had inside the container. Yeah, and yeah, then we use this function to open the file, and this is kind of work. Let me show you if it works. Let me print success, fully open the video. Yeah, let me demonstrate it. Let's see if I move the video in here. Let's move this video, basic window in it, window project. Yeah, I think we want let's that second argument, then let's compile it. String cap or test2, link our library using pkg config, c flag lib. I think I forgot auto library. What does it do, the auto library? Yeah, I think AV codec, format, util, the scale. Yeah, test2, and the file name basic window init. Yep, we don't have to care about this, but that's the thing. This function work. This function work. Wait. Did I do something wrong? Oh, wait. I have MVAC example. I think I have MVAC example. Example code. I think we have some example here. FFmpeg example. We need to open the file. Scale. Wait. Change code. Scale. Where's open? Where's it? Wait. Muse. Where's, yeah. This one is what we should do. Cons. Oh, we need cons. Red. This is what we should do. This is the very first step. We need to show the metadata. Yeah, okay. I think we can rewrite it in this way. Okay, it's recording. Just make sure. This tutorial is really old, but it kind of show us the overall step of how to do it. So I think this should be good if we try to follow this new one. Leave AV format. I think we can AV format. Okay. Yeah, I think we don't need this one. Yeah, I think we don't need this. AV format, cons, AV, live AVU2. Let's go live AVU2. Include AVU2 dig.h. Don't overthink this work. That doesn't mean anything. It means something, but not what you think. AV dig scenario entry tag equal no. What does this do? Okay, in red. Let's check for the command like argument of C not equal to fprintf st. This is a good practice that I learned from my professor. Here we use fprintf str, and I think we can copy all this. Oh, no, let's type it manually. You say %s as input file dot end example program to demonstrate the use of live AV format. Metadata API dot and wait, I think something is not right. Do we need a comma? Do we need a semicolon? Something like this? Oh, I think we need this. I think we need that. And I think I did something wrong. And zero. Wait, let me just how many arguments there's in take C documentation printf constant char okay. I think we don't need fprintf. Yeah, I think we don't just need one of that. Input file. Yeah, I think we don't need that. Zero. Wait. Yeah, I have a better idea. Include lib.a. The reason why I want to use library because exit failure. Is this failure? Yeah. Then for the second, if red equal AV format, open input, and we gonna pass the address of the pointer p format of 1 comma no is red? Return red. What is red? And another if. Red equal AV format. AV format. File stream info. P format. P format. No less than 0. What does this do? Use AV log. No AV log. Oh, we use error cannot find stream information. Return red. Okay, while bye bye. This one. While tag. So we have to go to a loop. Tag equal AV dictionary iterate P format metadata tag. Yep. Printf %s send as s equal %s and tag get a key tag value. What does this mean? AV format. Okay, we have to close it. AV format. Close input. The address of the P format. Then we close it. Semicolon. We'll try to compile it. Yes, it works. Does it really work? I don't know how this works. Okay, do we have to print anything? AV log. Wait, what is tag? Dictionary. What is red? Definition. Filter design. Input. Oh, I think we had a constant in here. We had this. I don't know why it is like that. Segmentation for. Wait, does this really work? Print to few argument. Yeah, let's see it. I haven't compiled it yet. Yeah, makes sense. AV sorry, AV dictionary. My bad. AV dictionary. Okay, my bad. Bad typing. Okay, so it's missing a closing bracket. Sorry. Cool. AV log error 80. Sorry, my bad typing. I typed too fast. Yeah, I should slow down. Okay. Too few arguments. Wait, what if I change it to the std you say %s input file arg0. Okay, let's try it once again. argc argv. Oh, my bad again. To you say it's worked correctly. Basic success. Does this really mean it work? Minor version compatible. Asian time encoder OBS Studio. Yes, so good. Thank you mom, thank you dad, thank you everyone. Okay, that's it for today. Yeah, that's how you reorder metadata. Yeah, by opening a file. That's how you open it. Cool. So we need to store the data. Need a way to store the data. Find the decoder. Oh wait, I think that's include a lot of steps. We don't have to manually follow this. We can move to the next one. That's all. The next one should be this one, storing the data. Yeah, we find all the. Yeah, we have everything we need. Oh, cd document, cd window project. Yeah, I think major brand ISO 4 minor conversion encoder. Yes, we have the encoder and the decoder. Copyright. No, there's no copyright. Find a decoder. Do we need a decoder? Find decoder. Do we have it in here? Find stream, open input. No. Yeah, do we need to find a decoder? Yeah, I think we need to bring the decoder. That should be for the next step. Transcode, decode video. No, that should be for the next step. Cool. Okay, that should be for the next step. So far, we open the file and we have all the metadata like the encoder, the name, the tag, the software. Yeah, pretty much everything works. Okay, so next step, I'm going to edit the video. So bye guys, good night. It's 2:55 in the morning. Yeah, I will be back tomorrow. Bye bye. Stop recording.